Please join me in welcoming Mr. Ryan Kim, JKP lead. He will diving into the intriguing topic of how do we optimize Halo2 with Tachyon. Ladies and gentlemen, please give a big applause to Mr. Ryan. The stage is yours.
1, 2, check. Hello everyone, I'm Ryan Kim and I'm ZKP lead on the Chroma team. Okay, today I'm so excited to present about the latest advancement for the field of ZK-EVM. And first, we're going to take a quick look at both Chroma and Tachyon and dive into benchmark result in comparison with Scrolls Halo2, if you heard of it. And I'm going to explain the straightforward migration process from Halo2 to Tachyon. And then I'm going to explain the sum of strategy that we've employed to make this result. And last, I'm outline our exciting plans for the future. So, what exactly is Chroma? Chroma is the first opposite rollup with active ZK proof, and it's essentially an optimist rollup powered by ZK-EVM. And this design was chosen primarily due to the challenges that is related to the ZK-EVM's cost and time. And we recently achieved historic milestones that for the first time ever, active challenge took place on our mainnet of universal rollup. And Chroma ZK-EVM currently depends on Scrolls Halo2 for both front-end and back-end, but we are confident in enhancing the back-end performance with Tachyon using GPU acceleration while keeping the circuit part untouched. So let's dive into Tachyon. It's a modular GK backend accelerated by GPU designed to maximize the GPU utilization ratio. So let's consider the optimal use of a GPU. The field that immediately comes to mind is deep learning, right? And deep learning model is often developed using Python. But internally, when leveraging GPU acceleration, they rely on C++. So why is that? Well, using GPU means you have to write code with NVIDIA SK, and we are only provided with C++. Then let's shift our focus onto the blockchain, and which language do we tend to use more for ZK? Is C++ or Rust? Of course, Rust, right? And Rust is an excellent programming language, but when considering implications of using Rust with GPU for ZK, is that it requires rewriting some part of your code in C++ again, such as MSM or NTT, which results in some performance drawback because some of your there's a limit which limits how much of your code can effectively run on GPU, and this results in performance bottleneck, and because one section of code can effectively run at a time. So our vision with Tachyon is to transcend these limitations by enabling for entire source code to run seamlessly on a GPU by ensuring that GPU is fully utilized without any downtime, ensuring that performance improvement across the board. And to achieve this goal, we initially implemented the Halo2 CPU version in Tachyon, and guess what? We outperformed Scrolls Halo2 by 10%. And this is particularly noteworthy because despite requiring for simple migration, additional requirement for simple migration, it still surpasses our expectations. Although it was slower before theta phase, but Tachyon improved performance after theta phase as it gains all the necessary context to generate a proof. And moving forward, we are fully committed to enhancing the speed for all the phases it involved. And not only have we made Tachyon faster, but also we have reduced memory like 30%. Put simply, there are two ways to represent polynomials, which is one is the coefficient form and the other is evaluation form. And interestingly, we don't have to maintain both forms at every phase. Rather, one form is required at each phase. And however, Halo2 maintains both forms for all the polynomials except for advice column. So after recognizing this inefficiency, we resolved this issue and successfully reduced like approximately 32.62 gigabytes when proving supercircuit of GK EVM. And the migration from Halo2 to Tachyon is just straightforward. All you need to do is to modify around 20 lines in backend part only. And most importantly, you don't need to modify your circuit at all. Typically, sequence to generate a proof follows these steps: defining your circuit, generating the parameters for the polynomial commitment scheme, and generating the proven key, and creating the random number generator, creating the transcript, and creating the proof with all the arguments above. And it's worth taking a note that for Tachyon is that step 1 is not modified as we wanted to keep the circuit part untouched. Tachyon needs additional context, and we can obtain this context by serializing the proving key, which introduces an additional overhead which is unique to Tachyon, amount to be like tens of gigabytes. And subsequently, similar structures should be created from the C++ instead of Rust, and by ensuring that the production of identical proof. And here are the optimizations we have done so far and are planning to implement, which are lazy IFFT, batch normalize, optimizing polarization, reducing heap allocations, optimizing MSM, entity, ship-wrong prover, H-poly builder, reducing redundant polynomial evaluations, creating unpermitted table just once. Those are well documented in our GitHub repository. So if you are curious about this, please come visit our GitHub repository, and we are welcome for you guys as a developer to contribute to our GitHub to resolve one of these problem list. And Tachyon is also listed in Halo2 ecosystem like here, and thanks to the overwhelming interest from developers, Tachyon once topped a chart on C++ weekly top trending, and at that time, which is above Bitcoin, and earning more than 7,700 GitHub stars. And we are confident in our source code becomes one of the best C++ source code over entire ecosystem, and we believe that our project will be loved by everyone and proves invaluable in various fields. And this project is also already comprised of over 140,000 lines of code. And for the next milestones, our plan includes several key objectives. We are exploring the possibilities of running Halo2 entirely on GPU, and we're going to apply folding schemes to Halo2. And since this is designed as modular, we are fully committed to supporting as many front end as possible, and Circum supporting is almost completed, and with Halo is the next targeted front end. And lastly, we'll continue to do more optimizations for further enhancements. If you want to learn more about Tachyon, please scan this QR code, which direct you to our Medium article. And the links are on the left side is about Chroma, and the QR code on the right side is a QR code which take you to the Tachyon GitHub repository, and you can reach out to me with Twitter or Telegram using this contact information below. That's all. Thank you for listening. Have a nice time in Vietnam.
Thank you, Ryan.